Mars, the next giant leap for humanity. But before we can plant our boots on the red planet, we need to conquer the challenges of surviving in one of the harshest environments known to us. From turning Martian air into breathable oxygen to building homes out of alien soil, here are the top 10 technologies and their degrees of maturity that will make a manned Mars mission possible and pave the way for humanity's first interplanetary colony. Let's dive right in. 1. Life support systems. Sure, we've used basic systems on the International Space Station, but Mars is a whole new level. We'll need advanced, closed-loop recycling to turn urine and even sweat into drinking water. Yep, that's a thing. Ultimately, fully autonomous systems will help keep astronauts breathing and hydrated for months, even years on end. The best we have so far is NASA's Environmental Control and Life Support System, ECLSS, which has been in continuous use on the ISS since the mid-2000s. Systems like the Water Recovery System, WRS, and the Oxygen Generation System, OGS, routinely recycle water and generate breathing oxygen for astronauts. Reliability has steadily improved through iterative upgrades and replacements. For low Earth orbit missions, many ECLSS components are effectively at Technology Readiness Level, TRL 8 or 9, meaning they're flight-proven in an operational environment. However, fully closed-loop ECLSS with near 100% recycling of water and air is still not realized on the ISS, where it's closer to 90 to 95% water recovery efficiency. In-Situ Resource Utilization, ISRU. Next, In-Situ Resource Utilization, or ISRU. Hauling everything from Earth is expensive, so why not use what's already on Mars? NASA's Perseverance rover is testing the Mars Oxygen In-Situ Resource Utilization experiment, MOXIE, a small device that converts Martian carbon dioxide, CO2, into oxygen, O2. It's essentially a proof of concept for producing breathable air and rocket propellant on Mars, reducing the need to bring large amounts of oxygen from Earth for future crewed missions. Future ISRU tech aims to extract water from ice and produce methane rocket fuel, setting the stage for a self-sustaining colony. But to enable humans to survive on Mars, oxygen and water would have to be obtained in large quantities on site. 3. 3D printing. On Mars, you'll only have the tools and spare parts you can transport in the rocket. That's where 3D printing comes in. Imagine using Martian regolith, the dusty soil, to build habitats, tools, and spare parts. This tech could slash launch mass from Earth and let us construct entire structures right on the red planet. Many technologies on our list are still in prototype stages, but 3D printers are already mature here on Earth. In fact, the German Aerospace Center, DLR, and the European Space Agency, ESA, have also developed regolith-based 3D printing techniques as part of the Regolite project for the Moon. 4. Heat shield and EDL. Landing on Mars is tricky. The atmosphere is too thin for standard parachutes and too thick to ignore. Enter Advanced Entry, Descent and Landing EDL systems. Think inflatable heat shields and supersonic retro propulsion to precisely drop heavy cargo and eventually astronauts onto the Martian surface safely. For SpaceX, this is currently one of the trickiest parts, and we made our own video about this topic. 5. Habitat design. Once we've landed, we'll need a home away from home. Habitat design is key. Inflatable modules like Bigelow's Beam could be a good start, but to survive on Mars in the long run, we need robust, radiation-resistant habitats. Future prototypes like NASA's Mars Dune Alpha could be the blueprint for comfortable, long-term living on the red planet. There could also be underground bases or habitats inside caves. So far, we've no long-term data on humans living on other celestial bodies. The Apollo astronauts were only on the Moon for a few days. Instead of testing many of these technologies extensively on the Moon first, SpaceX wants to skip straight to Mars and send the first robots there in just a couple of years. 6. Advanced spacesuits. Spacesuits used on the ISS won't cut it on Mars. We need advanced spacesuits. Lightweight, flexible, dust-resistant, and built to handle the planet's extreme temperatures. These next-gen suits will keep astronauts safe and nimble while exploring canyons and collecting rock samples. Currently, there's no fully operational Mars-specific spacesuit, only prototypes that still require significant development. 7. health and medical technologies. Space can be tough on the human body. Health and medical tech like telemedicine, AI-assisted diagnostics, and solutions for bone loss will be vital. Think advanced exercise equipment, rapid testing kits, and maybe even 3D printed organs in the far future to keep our Mars pioneers healthy. The biggest health risk on Mars, however, remains radiation, which significantly increases cancer risk. We've made a separate video about this topic. 8. Psychological and behavioral health support. Mars missions mean extreme isolation and stress. That's why psychological and behavioral health systems are crucial. Virtual reality can help astronauts escape monotony. AI tools can monitor mental well-being, and thoughtful habitat design will offer privacy and personal space. A happy crew is a successful crew, and these technologies already have a high degree of maturity. 9. Robotics and autonomous systems. Mars is no place for a quick fix if something breaks. Robotics, like Tesla's Optimus and Autonomy, step in to handle maintenance, scout for resources, and even build structures before humans arrive. Rovers like Perseverance and drones like Ingenuity are just the beginning. Future bots will be our tireless Martian workforce. Drones and satellites in Mars's orbit could also help keep an eye out for dust storms and other dangers. 10. Bosch Reaction Reactor. Finally, the Bosch Reaction Reactor. Mars's atmosphere is 95% carbon dioxide. This reactor can turn that CO2 plus hydrogen into water and oxygen, essential for breathing and fuel. While it's still in development, it could complement MOXIE and other ISRU methods, giving us multiple ways to generate life support and rocket propellant. And there you have it. 10 technologies paving the way for humans on Mars. From water recycling and oxygen generation to radiation-proof habitats and next-gen spacesuits. Each piece of the puzzle is vital. Ready to explore the Red Planet? Let's make it happen!